Hello, Proviso students, and welcome to the notes on solving quadratic equations when the equation is in factored form. So let's begin by just talking about how some basic properties of mathematics, and that being that when we have a product that's equal to zero, that is when we have one factor times another factor, and the result is zero, then one of those factors has to be zero. So looking at examples of these, this first example, I'm going to call it A. We have 3 times some unknown quantity A, and that product is 0. So what do you have to multiply 3 by to get you 0? Well, 3 times 0 will give me 0, so A has to equal 0. And let's look at example B, the middle one. Now in this one, I have 3 factors, and factors are quantities that you're multiplying together. So I got negative 4,000 times 3 10,000s times some number or value that gives us a product of 0. Well, negative 4,000 times 3 10,000s will give you another number, and you take that number times something will give you 0. That something has to be 0, so the variable b has to equal 0. And then this last example, I'm going to call it C. We have 24 times the quantity of x plus 3. So I have one factor, which is 24. And the other factor is that binomial x plus 3. Well, 24 is a constant. That never changes. So I'm going to 24. But the only way I'm going to get 24 times something that equals 0 is if that something, that other factor, is 0. So the factor of x plus 3 has to equal 0 in order for this statement to be true. So the question is, when does that equal 0? Well, when x is equal to negative 3. And this is the basis of how we are going to solve these equations when the quadratic is in factored form. So let's just write some examples of quadratics that are in factored form and some in which quadratics are not in factored form. So one example is something similar to the examples we just saw, and that could be something like the quantity x plus 3 times the quantity of 2x minus 5 equals 0. That's a quadratic equation in standard form, where if I have x squared plus 2x plus 3 equals 0, that is not a factored form. I'm actually adding the quadratic, the linear, and constant term together. That's standard form. All right, another way you might see these quadratics in factored form is you get something like 3 times x plus 1 times the quantity x minus 1, and that, let's say, is equal to 0. Well, once again, you have 3 factors. You got 3 times the quantity x plus 1 times the quantity of x minus 1. So all those factors are being multiplied together. So an example of a factor of another quadratic that is not in factor form could be something like 3 times the quantity x plus 1 squared plus 2 equals 0. That is an example of a quadratic in vertex form, not factored form. And then one more. Let's say we have x times x plus 1, that quantity, and we're just going to say it's equals 0. That too is in factor form because even though it's not shown, I could put that x by itself in parentheses. So that's one factor, x, and the other factor is x plus 1. So let's make the connection between what our solutions are and the work we've done with graphing quadratics. So we have this parabola right here that represents the graph of this equation, this quadratic in factored form. So what I want to do is we're going to draw dots on the roots. So the root is where the parabola touches the x-axis. So here's one root. There's another root. And we could write these two ordered pairs as, these two roots, as ordered pairs. So the first one, or one of them, will be 2, 0, and the other root will be a 4, 0. Now notice, if I go back to my equation right here, and I were to substitute in 2, so I'm going to let x equal 2, then y is going to be 2 times 2 minus 2 times quantity 2 minus 4. So I get 2 times 0 times negative 2. And anything that has, we're multiplying 0, or anything that's being multiplied by 0 is 0. So our y value is 0, which is what we have right there. And it'll be the same thing if I substitute 4 into this equation and went through and solved for it. The y would also be 4. So you may have noticed, you may have not, but one of the key patterns we see here is that the y coordinate for each root, and I'm actually going to put real root. So the y coordinate for each real root of a quadratic is equal to 0. That is why in our equations, we're going to let the y value equal 0. So we're going to let equations equal 0. We're trying to find, what we're trying to do graphically is find the x coordinates of the roots. So let's look at example A, and what we want to do is find the solution for this. So we want to find the values of x that makes this statement true, this equation true. And that's going to be true when either the factor of x plus 5 is equal to 0, or attention students, now 5:40. The activity bus will be leaving at 5:45. Attention students, the time now is 5:40. The activity bus will be leaving in 5 minutes. Students, if you have not made your way down to the bus will be parting in 5 minutes. All right, let's continue on. So, or we have the other factor of x minus 2. When will that equal 0? So let's look at this first one, the x plus 5 equals 0. Solve this algebraically. We subtract 5 from both sides and get x is equal to negative 5. That's one solution. Their solution would be to solve this equation of x minus 2 equals 0. We would add 2 to both sides and you get x is equal to positive 2. Now, just to show that this works, I'm going to go back to my original equation. I'm going to substitute negative 5 for the x. So I'm going to have negative 5 plus 5 times the quantity of negative 5 minus 2. So that'll be 0 times negative 7, which is 0, which is what we want our equation to equal. Likewise, the xb2 will have 2 plus 5 times 2 minus 2 equals 0. That gives me 7 times 0. And 7 times 0 is 0, which once again is what we want our equation to work. So both these values for x make our statement true. Now, example B, I have one factor of negative 3. Negative 3 is a constant. It's always going to be negative 3. It never changes. So that we can't really do anything with. But the factor of x plus 1.35, well, it can equal 0 for a particular value for x. And that value is when x is negative 1 and 35 100ths. But we can have a second value for x that'll make this statement true, the equation true. And that's when the factor 2 times x plus 5 is equal to 0. So to solve that two-step equation, I'm going to subtract 5 from both sides of the equal sign first. You'll end up with 2x is equal to negative 5. Then 2 times x, so you want to do the multiplication. You're going to do the inverse of division. So divide both sides by 5. The 2's will cancel, reduce, and you get x is equal to negative 5 halves. That's the second solution. So x could be negative 1.35 or x could be negative 5 halves. Now let's look at our example for C. We have x times the quantity of x minus 1 half. Once again, we don't have this first factor in parentheses, but I could create parentheses that are around there to indicate that we got this monomial of x times a binomial of x minus 1 half. So we're going to take this first factor of x and set that equals 0 and see if we have to do anything to isolate the x. We do not. X is already isolated. So that's one solution. The other solution is when the other factor of x minus 1 half, when does that equal 0? Well, if I add 1 half to both sides of the equal sign, then I get x equals 1 half, and that's my other solution. So x could be 0, or x could be 1 half. That's my answer. Now I'm going to give you a problem, try on your own. So I'm going to write down. I'm going to ask you to pause the video, work on it, and when you're done, start playing the video, and in a few seconds, I'll go over the answers with you, make sure everything's right. So here's your equation. Let's say we have 2x minus 3 times the quantity of x plus 4 equals 0. We want to find the roots for this. So go ahead, pause the video now, work on it, and then hit play, see how you did. All right, welcome back. Let's see how you did. Take your factor of 2x minus 3 and ask yourself, when will that equal 0? Well, solve for x now. Both sides of equal sign. I'm going to add 3. So I'll get 2 times x is equal to 3. Then I'm going to divide both sides by 2. So x comes out to be 3 halves. And that's one solution. Take your other factor of x plus 4, set that equals 0, and solve for x. So subtract 4 from both sides of the equal sign. You get x is equal to negative 4. There's your other solution. Put the word or between those two, and you get your solution. All right, so that's it. Doesn't get any more complicated than that. So good luck. We'll talk to you later. Bye-bye.